Question number 11 is kinematics. I have an expression for acceleration. So what is in my head? My head is already, I can integrate this, and the integral of that will be the inverse cosine of x on 2. So that's sitting in my mind that they've deliberately given me something that I can anti-differentiate. So it's acceleration in terms of x. I need velocity in terms of x. I've been given velocity in terms of x, and I've asked for speed in terms of x. So I need something that has v and x. So I need to replace my acceleration expression. So if I open up my formula sheet, and if I go down to calculus, I have different expressions for acceleration, and I'm going to choose either this one, because it's got v's and x's, or this one. I'm going to choose this one and use the separation of variables formula. So I'm going to have v dv dx instead of a equals -1 on top of the square root of 4 minus x squared. So that's the decision I made. So I have v's and x's. So the integral of v dv is the integral of -1 on top of the square root of 4 minus x squared dx. So what I mean by separation of variables, I'm going to put this dx over here with the x expression and leave the v with the dv and integrate both sides. So I've got a half v squared equals the inverse cosine of x on 2 plus some constant c, and I know that when x equals 1, it's equal to 5 root pi on 3. So we've got a half 5 root pi on 3 squared equals the inverse cosine of 1/2 plus c. So that gives me a half times 25 pi, 9 times 2 is 18, equals pi on 3 plus c. Therefore c equals 25 pi on 18 minus pi on 3. So 6 pi on 18 equals 19 pi on 18. So a half v squared equals the inverse cosine of x on 2 plus 19 pi on 18. Given x equals, remind me, root 3, find v. Therefore, on my calculator, that's that expression there. X equals plus or minus root 22 pi on 3. And since it's speed, I'll take the positive answer, which gives me D as being my answer. When I did my cut and paste, I lost the top of my square root, but in the question, that's there. So D.